everyone, welcome back to my channel. It's me, Alicia. Did you know that 70% of Java bugs in automated tests, it comes from the wrong data type for a variable? That's right. Something as simple as picking the wrong container for your data can break your test. It causes hard to find errors and even crash your app before it reaches the users. That is why learning Java data types isn't just a technical detail. It's a foundation for writing reliable and bug-free code. To make our content relatable, let me ask you a few questions from your daily lives. Have you noticed how different foods needs different bowls in your kitchen? You might use a small bowl for oats, a big one for salad, and mug for your tea. Each bowl is just right for what it holds. Now, try pouring your soup onto a plate. You will have a mess. Answering these questions now, you should be able to easily relate to it, and you would by now know where I am going to. Yes, the Java data types. Java data types, it works the same way. They help your code organize and store different kinds of information, making everything neat, safe, and easy to test. In this episode, I'll show you how data types are like choosing the right bowl for your ingredients and how this simple idea makes your automated test clearer, safer, and more reliable. Question of the hour. What is a data type? A data type in Java is a label that tells your program what kind of a value a variable can hold, just like your kitchen bowls are meant for specific foods, as we already discussed about. A bowl for oats, a cup for tea, and plate for your bread. In Java, you pick a data type for each of the variable. Let's move on to the code. First, let's create a class for it, and then we added the public static void main to it. Let's start declaring the variable int oats quantity equals 2. Basically, these are whole numbers. And the next is double milk quantity equals 0.5. These are decimal numbers that's actually used to represent half a liter of milk. We'll add boolean is hot equals true. These are boolean values. Now, here is a quick reference table for all your primitive data types in Java. So now let's go through different data types we have. The very first one is byte. Byte is having a size of 8 bits and its default value is 0. So for example, let's consider 100. Basically, why do we use it? These are small integers that saves memory in large arrays. The next is short. The short has a size of 16 bits and its default value is 0. So let's consider for an example of 200,000. And why do we use it? We use it in cases wherein we have to store larger integers and also for the memory saving. Let's go to the next one that's most commonly used, that's the int. Int has a size of 32 bits and its default value is 0. So it counts for any number of like larger values like 123,456 is what I have an example as of now. And these are basically the default for whole numbers, and this is the most widely used data type. The next one is long. Long has a size of 64 bits and its default value is 0L, and it consists of really long numbers, that is very large whole numbers. Let's move on to the next one, that is float. Yes, this is most commonly used after int. For all the decimal values, we take float in almost all our coding standards. So it has a size of 32 bits and it has a default value 0.0f. So we stored its example values 3.14f, and these are decimal values, but it has less precision. And the next one is double. Double is its size of 64 bits and its default value is 0.0d. For example, this has 3.14 blah blah blah. Basically, these are decimal numbers and that has more number of precisions. We use it for mostly of the mathematical calculation and as well as in the financial industry, we use it more because we might not need to trim the precision. And if we want to have the precision as it is, we use double for it. And the next one is char. What is char? Char has a data type of 16 bits. It's basically the default value is a /u000 and example values. Basically, these are for single character and letters, symbols, and all those things. And the next one is again widely used as boolean. It has a size of 1 bit and basically it's a logical values. So the basic default value is false
Either we use just true or false for it. And yeah, that is about boolean.
You will be just wondering, am I going to use all these data types into my automation script? No. In normal scenarios, I just prefer int, double, caret times, and mostly boolean for the automation scripts. But knowing the others helps you write more efficient and precise code. Now let me get into my personal experience of how I use data types in my daily work schedule. So, how mastering Java data types improved my code accuracy? Mastering Java types made my code more accurate by ensuring each variable held exactly the kind of data I intended. For example, using double for financial values, it eliminated the rounding errors, while using int for counts, it avoided accidental decimals. This attention to detail meant fewer logic errors and more predictable results in my automation scripts. So the next is, what errors did I prevent by using this? By understanding primitive types, I prevented some of the type mismatch errors like accidentally assigning a decimal to an int variable. And also the most important part is the memory wastage. By choosing byte or short for large arrays of numbers instead of int. And the next is the precision loss. By using double or big decimal for calculations, needing exact results, especially in financial or scientific contexts. Sometimes I do start asking these kind of a basic questions in all the interviews just to understand the in-depth knowledge that person has in Java. And also, moreover, whenever I ask them to write the code, this is what I look on to. What are the data types that he has used? Does he has a proper understanding or a foundation of Java? Have you ever thought of how Java data type influences the performance of your project? Choosing the right data type, it directly impacts the performance and the memory usage. For example, when you use a byte or short for large data sets, it saves memory, while using int or double, where appropriate, ensures efficient calculations. This optimization leads to faster, more scalable automation tests and applications. So let's move on to the next topic, that's the type conversions in Java. Understanding type conversion, that is two types, one is implicit widening and one is explicit narrowing, is really crucial for testing because it helps me avoid data loss and unexpected behavior during assignments and calculations. For instance, converting a double to an int without explicit casting can cause errors or loss of precision, which could make a test fail for the wrong reason. Knowing when and how to cast types, let me write safer, more reliable test code. So now let's go to what is implicit widening. It is called as automatic type conversion. In Java, implicit widening happens automatically when you assign a value from a smaller data type to a larger data type. The compiler handles this for you because there is no risk of losing data. Think of it as pouring water from a small cup to a big bowl. You don't lose anything. So let's go to the some real life code.
Int oats equals 100. Long, large odds equals oats. So basically this is into long conversion and it is automatic. Float, oat weight equals large odds. So this does a conversion from long to float and this is also automatic.
I hope now we have got a good idea about what implicit widening is about. Now let's move on to explicit narrowing. That is called as a manual type conversion. Explicit narrowing is the opposite. You are trying to fit a value from a larger data type into a smaller one. Since this can cause data loss like pouring soup from a big pot into a tiny cup, Java forces you to do this manually using a cast. For example, let's go into the real world scenarios.
Double milk volume equals 9.78. Int rounded mill equals, I'm casting int here, volume. This is called a manual cast wherein you convert it from double to int. This will cut off the decimal part. So rounded milk will become 9 instead of 9.78.
Implicit widening, it keeps your test safe from accidental data loss when moving to bigger containers. Explicit narrowing, it makes you double check your logic so you don't accidentally lose information or introduce subtle bugs. Especially important when you're validating edge case scenarios or comparing your expected results versus actual results.
So let's take a look onto this type conversion table. The first one is implicit widening. It goes in the direction of the small to large. Basically, from the example we saw earlier, it's into long conversion. So it is automatic and there is no risk of data loss here. So one of the use case we have used is the counting steps and then you want to calculate the average of it. Let's move on to the next one, that is explicit narrowing. That comes from the direction of from the large to small when you convert. For example, when you want to convert double to int, and this is not automatic. One of the example we saw is a casting one. And then there is a risk of data loss here because you're passing decimals as whole numbers.
Understanding and using these conversions correctly, you will write tests that are safer and more reliable, catching bugs before they reach the production. Why do data types matter in testing? When you're writing automated tests, you need to make sure your code handle different kinds of data correctly. Java won't let you mix up numbers and text by mistake. Even if you have a mistake, Java doesn't allow it to. So to sum up, Java data types are like choosing the right bowl for your ingredients. They keep your test data organized, safe, and easy to understand. That's why data types are a key part of writing clear and reliable automated tests in Java. If you have got a real understanding of the basic of what Java data type means, please don't forget to subscribe my channel, like my video and share my content as definitely it helps me a lot. And thank you guys for watching and happy testing. See you on to my next video. Bye.